In our previous section, we talked a lot about what makes something a function or not, and we're going to continue to talk about functions a little bit more, but specifically today we're going to go back to your function notation. So we're going to kind of go back to your algebra days a little bit here before we get too far into the geometry stuff. So in this section, kind of what we're focusing on here is the function notation and how to read it and how to use it. And then how can we start plugging in values to actually evaluate functions, okay? A function is, in my opinion, fancy language for an equation, okay? So in the past, you maybe in algebra saw a lot of equations that looked something like this. Y equals 2x plus 4, okay? That's an equation of a line, all right? Now, if they wanted to write this in function notation, instead of saying y, they would write it like this. Okay? Now, how we pronounce that is we say f of x. Okay? That's what function notation is read as. We don't say f parentheses x, we say f of x. Okay? Or it could be g of x, h of x. The letters can change depending on maybe what they're using in the problem. Okay? But you can see how everything pretty much looks the same except for that beginning piece. And so you're going to see, like down here in our notes, we've got an f of x here, we've got a g of x on number 2, we've got an h of x on number 3. So all of those are just giving you a different way to think about using these equations. Okay? Now, why do we have function notation? Like, why is this even a thing? Well, because sometimes when we're looking at equations, we're maybe just trying to imagine any point out there that we could be plugging in. And we're trying to maybe think about a way to represent that in our math language, okay? Not everything is going to have an x and a y. So instead of always just relying on those, sometimes we want to use that function notation because it's also going to help us in the future when we start having a lot of equations that we're maybe working with at one time. I'm not necessarily saying that we're going to be getting into that in algebra, but in geometry, but next year, when you guys are in Algebra 2, there's going to be times when you're working with more than one equation. You're going to have a process at one point where you have to solve a system of equations that has 3 equations with a lot of variables in them, okay? And so you may not want to see y equals y equals y equals for all of those equations. They maybe want to use f of x, g of x, h of x, so that you can start to differentiate the different types of equations that you're going to maybe see, okay? So that's kind of why we have the function notation, or at least that's a reason why I could think why we would have function notation. I'm sure there's many, many more out there. But specifically what I want to go into today is how to work with functions, okay? Like I said, you did do this in algebra. You may not remember it. Depends on how good your memory is there from what you would have done at the beginning of the last school year. But I'm going to kind of go over it like we've never seen this stuff before, okay? So when you're given a function, and it has f of x or something like that written in it, and then it has this piece afterwards, like the actual meat of the equation. So in this first one, it says f of x equals 2x squared plus x. That's the equation that we're working with. They then want us to find, and then it says f, and then 4 is inside the parentheses now instead of a variable like x was. All that means is that you're going to want to put that 4 in for wherever you maybe see a variable. So anywhere that you see an x, that's where you're going to want to put the 4 in, okay? So when I look at this equation up here, I see 2 and then x squared. Well, instead of writing x, now I want to put in a 4. And this is when you're really going to want to make sure that you use your parentheses, okay? You don't want to just write 2, 4 squared, because then it's going to look like 24 squared. That's going to be way bigger than if you take 2 times 4 squared. So anytime you're plugging something in, and I'm sure you talked about this last year in algebra, put parentheses around the pieces that you're substituting in so that you don't think you have different numbers than what you really should be working with, okay? And then we still have plus x. And again, instead of x, we're going to write 4. Now this time, I'm not going to put parentheses around that because it's just an x. There's not anything attached to that x, or we're not doing anything to that x. So I don't have any concerns right now that that plus 4 is going to kind of throw me off or make me make a big mistake or something, okay? Once you've got it plugged in here, all you have to do is solve it. So start using your computation skills here to be able to figure out what the answer is. So remember for order of operations, okay? Please excuse my dear Aunt Sally. Parentheses, exponents, multiplication, division, addition, and subtraction. You want to go in that order when you're starting to solve these things. So I see parentheses. I see 4 squared. So that's going to become a 16. So I have 2 times 16, and I still have plus 4. Okay? Multiplication comes before addition. So 2 times 16 would be 32. Plus our 4. And that's just going to equal 36. That's your answer. Okay? What this means graphically, so again, if I'm going back to my algebra days, if I needed to put this on the graph, what this means is if I went to 4 on my x coordinate, so if I went right 4, my y would have to be graphed all the way up at 36. Okay? That's a pretty big number. That would be kind of hard to graph, especially if you had limited space, okay, to make your graph there. But this is just allowing us to look at any point on the graph, not needing to rely on graphing the points. We're just using our algebra skills to evaluate this. All right? All right, if we look at number 2, we have something very similar here. We've got g of x. Okay, all they did is switch that f to g. That does not change anything about how we do this problem. Okay, and then it says equals negative 5x plus 1. We want to figure out what g of 11 is. So what is this equation going to equal if I put in an 11 for my x? All right, so we've got g of 11, and sometimes, I didn't write this on the first one, but sometimes you'll see people do it like this as well. They'll write g of 11 equals. So instead of doing g of x, they'll plug this in and put it right there. Okay, so I'm just going to add that to this one. You don't have to include that necessarily. It might just, for some people, it's helpful to remember, like, what number am I plugging into x by just pulling that piece down. So we've got a negative 5. Don't forget the negative sign in front of the 5 there. And then in for x, again, parentheses is going to go around the 11. And then we have plus 1. Okay? Really watch your signs, especially when they throw in a negative like this. You want to make sure you're paying attention so you don't accidentally assume it's positive and then get the wrong answer because you're working with the wrong numbers. So, multiplying first, this would be negative 55. Plus your 1 would equal negative 54. And there's your final answer. Okay? Now, 3 is similar. Okay? They again changed it from f or g. They now have an h of x. All right? Again, it makes no difference. I said earlier the reason why they're probably doing this is to help you kind of keep these equations separate from each other instead of seeing y equals, y equals, y equals. If we had to graph all 3 of these on the same graph, I don't know if I would want all of them to be written as y equals 2x squared plus x, y equals negative 5x plus 1, because it gets kind of confusing quickly when you have a lot of x's and y's being flying around in your problems there. Now, 3 is a little bit of a challenge because they threw a fraction at you guys, all right? But it's not going to be super difficult to work with that fraction, so don't let the fraction freak you out. You can handle this fraction, okay? So remember what we're doing here is we're putting this 5, because it says find h of 5, in for that x. So you have negative 2/5. We're taking it times 5. Okay, so it looks like this. Remember your rules of fractions. If you need to, maybe think of it like this is as like a 5 over 1. Now, if you remember your rules with multiplying fractions, you multiply across the top, across the bottom. However, you can reduce before you multiply. So if there's anything in a numerator and in a denominator that you can maybe simplify, you might want to do that first before you multiply. So in this case, we should be able to reduce these 5s, right? Because 5 can divide by 5 and we get 1 there. So those are gone, basically. And what I'm left with here is this negative 2 over the 1, which is the same thing as just negative 2. Okay? So see, that wasn't so bad. Don't let fractions make you nervous, okay? And if you don't like computing with fractions, if you don't like to multiply, especially if maybe it doesn't simplify that nicely. Okay, because I'm going to be honest with you, they're not always going to be that nice and clean. Sometimes they're going to get a little bit messy. That's why we have the calculators that we do in here, because they work with fractions very well. So or even if you just want to maybe double check yourself, maybe you're having one of those days where you're just thinking, I think I'm right, but I just want to double check. I know I have moments like that. Grab a calculator, type it in, and confirm with yourself, okay? But don't let fractions freak you out, okay? They're not so bad. They work the same way. All right. So in the examples above here, each function had an input and an output. Which one were you given and which one did you have to find? I want you guys to think about that for a second. You were given in that problem, all three of those up there that we just did. There was a part of it that was considered the input, and there was part of it that was considered the output. Think about the process that we just did. Think about what we actually had to do to get those answers of 36 and negative 54 and negative 2. Think to yourself for a minute here, or I'll give you maybe 15 seconds. Think to yourself, what do you think we put in? Like, what was our input, and what do you think we got out as our output? Okay, think about that for 15 seconds. Okay. I'm hoping that this is just using words that will help make this a little bit obvious to you, okay? But what did we put in for all of those equations? We put in values for x, right? We put in a 4, and we put in an 11, and we put in a 5. So all of those values that they had here, so all of these would have been what we put into the equation. So therefore, shouldn't that be the input? It's got the word in it, right? It's a lot of ins to say at one time. Then what you got out, so your answer at the end. So this 36, the negative 54, the negative 2. That's what you got out. So doesn't it make sense that that would be our output? I'm hoping that that makes sense to you guys, okay? So down here we're going to say we were given the input, which we'll call x, okay? And we found the output, which would be your f of x notation, or the g of x, or the h of x, okay? Remember, those are changing depending on maybe what they're using for letters in the problems. But the number that you're plugging in, that's just an x value. That's a certain x point that we've picked that we're going to evaluate our equation at. What we get out is our y value, but remember, we're not saying y all the time. We're saying f of x, g of x, h of x to kind of keep those equations separated. Okay? All right, now, look at these next three here. They want us to try these examples as a group, okay? We want to make sure that we read them carefully. It might take you a couple times to figure it out, okay? So you really want to look at what are they providing us with. Look at the notation that they give you, okay? Because they're not just going to want us to do them all like we just did. We don't need to just plug and chug on all of these. Sometimes they want us to solve for maybe what we had put in, depending on what the notation is providing us with, okay? So before we even get started here, I want you guys to just look at these three, 4, 5, and 6. I want you to look at maybe what they're providing us with, and maybe what are they asking us to find. So I want you just to kind of think about that, maybe brainstorm what you think is happening here. I'm hoping that you guys are noticing that these are written a little bit different. They still have the function part that we saw earlier. You know, they say f of x equals 8x minus 5. You know, we saw something like that earlier. And same over here and on this last one. So like that isn't different. What's different though are these second pieces. I'm going to underline those in this orange color. What are those pieces? Are they the input or are they the output? hopefully, based on what we talked about from just a little bit ago, that you're remembering those are the outputs. That's what we would get at the end if we evaluated the equation at a specific x value. So unlike those last three where they were giving you the x to plug in, they're not doing that for these ones. Okay, they have it written just slightly different there by giving you the output. What does this mean then as far as solving it goes? What we're going to have to do here is instead of taking negative 29 and plugging it in for x, you are not going to want to do that. Okay? That would be wrong and you're going to get a way, way out there answer. Okay? What we want to do instead is you're going to take the equation that you have, so this f of x, the part that I underlined in green, you're going to set that equal to this part that we have underlined in orange. Okay? Now, if you really want to get technical, remember that our equations from up above are written like this, f of x equals x plus a number or something like that. There's a lot of variations of that. So sometimes what students will want to do is they'll put that negative 29 first because that is the f of x piece. So they're going to put negative 29 equals 8x minus 5. Okay? Do you guys think it matters, though, if we set it up like that? Or could I maybe flip it around and say 8x minus 5 equals negative 29? You can flip it if you want to, okay? And some of you might want to, because a lot of times when we're in, like, our algebra mindset, last year when you were in algebra, you probably were told it's better if we have equals a number, have all the equation, keep the letter on the left side, keep the numbers on the right side, right? We were probably told that a bunch last year when we were solving equations. So if you don't like it written like this, you don't have to write it like that. You can flip it around. I have no issue with that. You could say 8x minus 5 equals negative 29 instead. Okay? It makes no difference to me how you write it. Now, once you've got it written, now you just have to go about and solve it. You're solving for x. So again, we're going back to our algebra days, and we're solving these equations for x, okay? So the first thing we're going to do here is I'm going to add this 5 over. And that gets rid of those on that side. So we have 8x equals negative 29 plus 5 would be a negative 24. And then we have to divide by 8. Okay? And so then over here, those are gone. And so you get x equals negative 3. There's your answer. Because you were trying to figure out what was x. Because it says here, what is the value of x? It says up there in the directions. What was x? What were you plugging in to make that happen? Okay? All right. I want you guys to take some time, and I want you to try to do 5 and 6 on your own. Okay? I'm going to pause for just a little bit here in my video, but you're probably going to need to pause the video yourself to give yourself some extra think time, because I'm probably not going to sit here for 3 minutes while I wait for whoever is watching this to do the problems. So I want you guys to pause your video here, take some time to do these problems. When you're ready to resume and see how these work out, then hit play, and we'll keep chugging along here, okay? All right, for number 5, you needed to, again, just like before, set them equal to each other. This time, I'm going to flip it to the other way just to kind of keep things interesting here, okay? So we're going to do 13 equals x squared minus 3. We're going to set it up like that. Okay? Again, if you flipped it around so that it looked like the other one, that's totally fine. I'm going to add 3. All right, so over here, those 3's are gone. 13 plus 3 would be 16 equals x squared. Right? Now, to get rid of an x squared, what do we need to do? The opposite of squaring something would be to square root it. All right, so square root, remember, is kind of looks like a division sign, but it's got like this weird little tail at the front of it. Okay, so we're going to square root 16, which would be 4, and that's going to be our x. All right, and then number 6. Again, I hope that fraction didn't freak you guys out. We talked about fractions before; they're not that scary. Okay, so you have 1x over 3. And if you need to, you don't have to keep the 1 with the x. We could just write that as x over 3, maybe. And then we set that equal to that negative 15. How do we get that x by itself? We got to multiply by 3. Okay? Since it's dividing by 3 right now, to get it out of there, you got to multiply by it. So we're crossing those off, and then over here, you've got negative 15 times 3, which would be negative 45. Good. Okay, in these examples, were you given the input or the output for the function first? What do you guys think? Good. Hopefully you said you're given the output, because we talked about that. They're giving you what you ended with, okay? Is there a way that you can recognize this difference? Like when I underlined things earlier, when we were kind of talking about this for the first time, and I underlined how they wrote that f of x equals negative 29 and h of x equals 13 and so on. Hopefully you just kind of noticed, well, that looks different. They didn't give us this. Like if they had said f equals negative 3, that would have been your input. Because that would have been what we plugged in to the x. So this would have been your input, where this, I'm going to draw an arrow here. I don't want to confuse you with a lot of equal signs there. That would be your output. So I'm hoping you kind of recognize the difference here with how they're written. On an input, we don't see a variable other than the f, but that's talking about the function. But we don't see a letter inside the parentheses. We see an actual number. We're over here on the input. We have a letter inside the parentheses, and there's an equal sign. Okay, that's kind of a big red flag, like, hey, I'm different. So those would be a couple things to just kind of look for when you're trying to figure out what am I supposed to do with the problems here. Okay? All right, so on the bottom of your page, it says right here, use this function, f of x equals x plus 5. So that's your equation that we're working with, okay? To determine either the missing output or the missing input. So they're going to give you either an input or they're going to give you an output. You have to decide where that number goes. So you have to figure out, if they're giving you something, does it go in for the x or does it go on the outside of the equation like what we just saw and we have to solve them? All right? I want to give you some time to try to do these and see if you can figure out language-wise what they're giving you down here and what to do with it. Okay? Again, you're probably going to have to pause your video here because I'm not going to sit and wait while I'm recording this. So I want you to pause it, do these 3, and then come back when you're ready to talk about them. All right. For this first one here, they are giving you an input. That means that negative 4, you need to put in for the x on the equation. So you're going to have like this, f of negative 4 equals negative 4 goes in for the x and then plus 5. So you should have just taken negative 4 plus 5 to get an answer of 1. Now number 8, they're giving you the output. So they switched it on you. That means that we don't know what they put in for x. We know what we got as an answer. So you're going to put negative 1 in for the f of x. So it looks like this. Negative 1 equals x plus 5. Okay, then we subtract 5. Negative 1 minus 5 would be negative 6. That'd be your x. So that would be your input. Your input would be a negative 6. And then number 9, the last one, is just like the first one. They're giving you the input. So you should have plugged in 2.5 in for your x. So 2.5 plus 5. Okay, and your answer there should have been 7.5. All right, if we turn to the back side of this page, we're going to continue to talk about these functions, but now, how do they relate to geometry? Okay, we've talked a lot about the algebra stuff. I'm ready to move on to talk about the geometry stuff. Okay, So when we talk about functions in geometry, we have a similar process where you have something that you put in and you have something that you get out. Okay, so we have an input and an output process just like we did before. When we talk about the input-output process, we determine how the points and how like your shapes that you're working with are altered or moved on the coordinate plane, right? Now remember, we were on the coordinate plane, our points are giving to us, as x, y, as a ordered pair. So x is your first point and then y is the second part of that coordinate. So that's just telling you like where is it at on the coordinate plane. Did you have to move left, right, up, down? Where did you have to go to plot that? So when we have these functions and how they're maybe being written in geometry, it's going to look a little bit different than what we saw in the algebra, okay? So right here in red, it says input. This would be, again, known as your pre-image. So this would be what happens before you did anything to your shape. And then your output, which would be your image. That's what they have written here in blue. That would be what you got. So like after you did the things to it, what does it look like now? Where is it at now on the coordinate plane? So, for example, when you have a coordinate from your pre-image, so you know where it is, you know where it's plotted, you should just be able to pull those points off of the graph, okay? So that's why they have x, y written there. When you have an output, something had to happen to that pre-image point in order to move it somewhere else on the graph or to change its location. So you can see how they wrote in here x plus 3 and y minus 6. Okay? What those are going to do is make your points move. And it's going to, depending on how they write it here, whether you have a plus or a minus and then the numbers, that's going to determine like how does it move? What directions does it go? Okay? So over here, in our words, like how I would maybe describe this to somebody, is that we're talking about coordinate rules here. Coordinate rules would be things that we do to these coordinates to cause them to change where they're at on the graph. All right? And coordinate rule that we see here maps all of those points, x, y, to x plus 3 and y minus 6. Okay? Maps, when they say maps here, what that means is moves. All right, so for example, if we have point A that has these coordinates 4, 2, then what this rule is going to do, all right, if we're doing x plus 3, so if I have 4 plus 3, if you think about what that would actually mean, 4 plus 3 would be 7, that's going to move your point to the right more because we're increasing its value on the x. So this is going to move right 3. And it says minus 6 here. So y moves either up or down. Well, since it's a minus, that means it's going to move down. So it's going to move right 3, down 6. So like what we see up here, when you move right 3, that means that you're adding 3 to your x. And when you go down 3, you subtract 6 from your y. That point 4, 2, that would be called your pre-image point, because that would be where we started. Okay, and this is just like the input. Okay, so right here you can write input. That's just like the input that we saw for our function. So the original points, those would be what we put into our coordinate rule. So that's what would make it look like the input, like what we put into our equations on the backside there. The new point, so like I said, if we use this rule that we have up here, and we take 4 plus 3, we get 7, and we do 2 minus the 6, that's going to give me negative 4. That's going to be called your image. Okay, so that's where the point goes to. So that's going to be a new location on the graph. That would be what we got out of it, so that means that it's going to be like the output. All right, so what I want us to do here is try the coordinate rules on these two problems here to figure out what would be the new image. So both of these, we have our coordinate rules are written up here. So we've got 3, x minus 1. That's what we're going to do to our x. And then we have 5y. I'm just going to try to underline them a little bit differently for you. That's what you're going to do to your y coordinate. So for our x here, we start at 3. So 3, this 3 here is going to go in for the x that we see up here. So it's going to say 3 times 3 minus 1. And this is going to be our new x point for our coordinate. So this would be 9 minus 1, which would be 8. So 8 is going to be your new coordinate, your new x. And again, remember this notation? We talked about this before. That little marking means what? Prime. Okay, so A prime would be our new point, and that one's going to be at 8. Now for our y, our rule up here is this 5y, and we're going to use the 2. So we're going to take 5 times 2, which is 10. Okay, so that's going to be your new point there, 8, 10. We can do the same thing over here for number 11. We've got two rules. We've got x minus 4, and we've got negative 3y, and you have your x is a negative 1, and your y is a negative 2. Go ahead, take 30 seconds and try to do this one. All right, so for this first rule here, you should have done negative 1 minus 4, okay, and that's going to be negative 5, so that's our new x. And then for the second one there, we've got negative 3 times y, so negative 3, and in for y, we're going to put that negative 2, so that's positive 6. So negative 5, 6 should be our new point there. All right, if you look at the last ones here, these are written a little bit differently. See how they're kind of switching it on us? They're not giving us the original point. They're giving us the coordinate rule, and they're giving us the new point. Now, how do I know that? Because over here where it says C prime, or D prime, that's the coordinate that they have listed for me. So this is where I ended. This is my output. Okay, this is my image. What I need to figure out is what was the pre-image. Where did it start? Okay, so we got to go backwards a little bit. So what we're going to do here is we're going to plug in, or we're not going to plug in exactly. We're going to be setting equal our rules to the numbers that we have out here in our output. Okay, so up here in my rule it says like 5x plus 3. We're going to set that equal to the 13. We're basically setting up equations like what we did on those functions on the previous page. And we're now going to solve for x. So we're trying to figure out where did the coordinate begin, and when I applied the rule to it, what happened to it? Like, where did it go? Okay? So we're going to subtract 3. So I have 5x equals 10. We're going to divide by 5. And we're going to get x equals 2. Okay, so that goes right there for that beginning point. Now we're going to do the exact same thing with our second rule. Now our second one says 7y, and we're going to set that equal to the negative 7. Okay, so just like what we did before, we're going to divide by 7. And we're going to get y equals negative 1. And that goes up there. Okay, so I want you guys to take 30 seconds here or so and try to do that last one. Okay, if you need more time, just pause this video and then hit play when you're ready to go on. So you should have taken the x plus 7, set that equal to -4. And then for the other rule, you should have set 2y over 3 and set that equal to a positive 4. Okay? To solve the first one, you just need to subtract 7. So -4 minus 7 would be -11. Okay, so that's for the x. On the other one, you need to multiply by 3. That way it gets rid of that in the denominator. So you have 2y equals 12 over here now. And then you divide by 2. That should give you a 6.